This presentation is a detailed overview of how to use tensor neural network libraries to solve feature extraction and classification of text and images. And the idea is to resolve retailers' problem of product attribute extractions, because product attributes that are provided are very cryptic. They are not very well formed. Sometimes they have translation issues, and all those descriptions that are provided for a particular product has to be then further classified in a hierarchy form. For instance, a class can have attributes, or a category can have an attributes like color, brand. So retailers usually they have to put a lot of effort or manual intervention in order to classify them properly. And so the basic problem or the resolution that we propose is not only use images, not only use text, but also reuse images in order to classify. The key usage of these product attributes are usually to further data mine. For an instance, as for consumer-centric behaviors, like what a particular customer is buying in a particular category, do they like high heels, or they like flat heels, or they are like a comfort customer. So in order to identify those, product attributes play a key role as they are input into assortment planning. Along with that, today retailers like to do a lot of targeted offers and promotions. Again, they try and concentrate on finding what their key product attributes are within a category. So that's something which is driven at the back end, where data is driving what retailer would like to see for a particular customer. Also, there is another aspect which is the customer behavior, where they would where customer online can come and search, and at that point image similarities can help in identifying what the affinities are, right? For an instance, if a user is looking for if a customer is looking for high heels or heels with very thin straps, at that point bringing another image or another product that is very similar to that particular product is something that helps improves the experience for the customer. Along with that, they can also have searchable images. So there are quite a few of use cases where a retailer can leverage image recognition and text classification, and then combine those two in order to identify their product attributes, so that they can eliminate any misclassifications, they can fill in any gaps and annotate images and for similarities and search capabilities. So from a customer perspective, if a search is done for a black sleeveless dress with red prints, something similar would help, right? Like like a customer would like to see not a long sleeve dress for sure, right? So that's the idea behind for a retailer to further identify these product attributes so that they can improve customer experience online. So the neural network selection that was done as part of this effort was first to do the image captioning, where image was read and then it was fed into multiple convolution layers, and then the completed layers, and the predicted classifier was identified. The other set was to use word-to-vec, which was used for text classification. And the last effort was the combined classification, where outputs of both image recognition, which is the convolution layer, was fed into this combined classifier along with the text. So the architecture looks something similar to this, and now we'll see what the results were. So before we first dwell into the results, first we'll look at what the data set was. Now, since this was focused on fashion, we had used ImageNet, but there were very limited classes in ImageNet dataset that were catered towards fashion. They had a lot of cats though. We also downloaded weights from a conversion utility, and then those were used in order to those were fed into the neural network. Along with that, there was one more fashion-related data set that was consumed by Virtuec, which was to identify for genes what are the possible descriptions that have been provided, right? And then dresses. So there were around 1,000 SKUs that were that I had used in order to do it. But yeah, if we have a good transaction data set, that will improvise the so the results that we had got was they were close to the image prediction was pretty varied. Depending on what type of image was used, I could see results varying. Some of the results were excellent, whereas some of them were really like a 0.8 range, or I suppose like if I feed in more images, I will see that it will further reduce. And the text was not bad, but my test data set was pretty cleansed, so most of them were in 0.98, 9.9. Some of the underlying issues that we can see, and that's the way the whole system will work, where retailer first run this in batch, where this training and predictions are done, and at that point it's all automated, and then user will come and intervene. And at that time, if text let's say text was not at all present and it was not even predicted in the data set, that becomes like a critical alert for the user to come and rectify those by themselves manually. Also, there can be cases where both images and text may not give good results, and they may end up like misclassifying. At that time also, trigger is required, an alert notification is required to identify that misclassification as something more of like a very difficult process, where you will see your predictions scores high. So that was something that still is not very clear how it will be. So these were the few websites where I had downloaded the data, and these are my YouTube video links. I'll go to my Word document, and we'll start walking through some of the architecture as well as the. So one thing I wanted to bring up was that image to text combined effort. I couldn't finish it, and I could see like I was trying to merge two of these models through TF concat, and I am getting some errors there. So that is something which I believe was a little tricky for me. So we will review, this is the architecture behind the VGG16 pre-trained model, and these were the layers which required like convolution block 1, block 2, block 3, block 4, and block 5, and after that fully completed layers were applied. So these were some of the results that I saw. So for an instance, if I am feeding in this image um, from ImageNet, the results that were identified were like jean, blue jean, denim. Those were the classes that are available in ImageNet, pre-identified classes. The similarity was around 0.8. And these were the further vectors that it further identified. So if we see it remain in the fashion domain, stole, I'm not sure how it got it. Then the next one, again, this image had a low score, although it's also blue jeans. Again, jean blue, jean denim was, and then sweatshirt and velvet and swim trunks. This remained in the fashion domain though. And then the last one, which was identified more because I think it's a close up, so that had the best score. Then the next one was text classification, and here word2vec was used, and we had tried to identify what are the most common words, right, available within that set. So the most common were like jean, dress, and solid. The next three common were like summer, denims, cotton, and so on. And the last three were like a sleeveless, square collar, and corduroy. My next attempt was to find out, because my purpose is that I have a description that a retailer has provided, which is pretty, like it will be like denim, raw, tight fit, light blue color, and so on, right? So it's like a big string coming in. So I had to feed in a vector, and based on that vector, I want to get another vector, which will give me more intuitive results, right? Like for an instance, it's a slim fit or wash. Stone wash, and those kind of other attributes that can be used to describe a certain. Ideally, this data set should also have jean and then the department like clothing and so on, so that hierarchy can be developed. Similarly, if we see for denim plus slim fit, we got slim fit, boot cut, low rise, capri, flared, like all the styles that are possible available in it. And then further running the similarities for each word. For an instance, jeans. So with jeans, mid-rise, shorts, straight legs, wash, denim, these were certain predictions that came. Similarly, for slim fit, boot cut, white, low rise, and for denim, these were possible combinations that came in. So now these can be used, and as I mentioned, that it can have a hierarchical data also that can allow retailer to further say that is this an attribute at the category level, or it's at the subcategory, or at a department level, and that way it can be created into a tree structure. So with limited fashion data set, if the images were only trained within fashion domain, we would have got better image classes, and that would have further improved right up front. Despite that text coming in, we would have got more details. So that is something that I see can be further extended, and I also believe that image plus text will be a better predictor. That's it. Thank you.